XL is equals to 2 pi times 1,000 times 0.05. So we have 314.15. So we can write up here, therefore our XL is equals to 314.15 ohm. And so we calculate for our XC. So our XC, that is capacitive reactance, XC is giving us 1 all over omega C, which is the same thing as 1 all over 2 pi FC. So by substitution, we have 1 all over 2 pi. Our F is 1,000 times 1,000 times 0.5 exponential -6. I told you that is the meaning of 0.5 microfarad. So our XC is equals to have 2 pi times 1,000 times 0.5 exponential -6. You do that, you're having 1 all over 3.14 exponential -3. So XC, so 1 divided by that answer, 318.3 ohm. So we can take it up here. Our XC is equals to 318.30 ohm. So we can clean this to find our Z. What is Z? So our Z is given to the roots of R squared plus brackets XL minus XC all squared. So by substitution, you have your 20 squared plus 314.15 minus 318.3 all squared. So let's compute quickly. Do that, you're having your 20 squared will give you 400. So 400 plus you have 314.15 minus 318.3. You'll be having, let's say that again, 314.15 minus 318.3. We're having minus 4.15 all squared. So that's square minus 4.1 square will give you, we're having 400 plus 17.223. So that plus 400, we're having your Z is equals to the root of 417.2225. So the roots of that. So therefore, your Z is equals to 20.4 ohm. So right up here, Z is equals to 20, approximately 20 ohm. Z is 20 ohm, so we can go ahead to find the current in the circuit right now. So from Ohm's law, we have V is equals to IR. So since it is our RLC series circuit, we replace our R with Z, the impedance, the total reactance, opposition to the flow of AC in the AC circuit caused by the resistor, the inductor, and then the capacitor. So our V is equals to IZ. So you make I the subject of the formula. So you have your I is equals to V all over Z. So by substitution, this implies that your I is equals to V, that is 25, divided by 20. What do you have? 25 by 20. What do you have? You have 1.25. So, therefore, the current that will flow through the entire circuit is giving us 1.25 amp. 1.25 amp. Because we have found the current, we can go ahead to find the voltage across the capacitor and then the voltage across the inductor. From Ohm's law, you have your VC is given to be what? The current times capacitive reactance. So voltage across capacitor VC is equals to the current, this is 1.25 times capacitive reactance times 318.3. So that times 318.3. What do you have? The voltage across the capacitor C is given to be what? 397.87 volts. So that is the voltage across the capacitor C. This is the voltage. So we can also go ahead to find the voltage across the inductor. The main questions they ask us in the question. So VL is the same thing as the current times what? The current times capacitive inductive reactance. So your VL is equal to the current, which is 1.25 times 314.15. So if you do that, you have 1.25 times 314.15. What you have? So therefore, VL is given to be 392.69 volts. These are the variables or the quantities they ask us to calculate in the question. This and this. So we are done with the question. Okay, we'll now look at some questions here before we call it a day for today. Let us solve this question quickly. Calculations in physics, page 405, exercise 5, question number 4. Let's clean this quickly. Question number 4, it reads, the voltage of the domestic electric supply is represented by the equation V is equals to 311 sine 3 T. Determine the frequency of the AC supply. They're asking us to find F. Determine the frequency of the AC supply. Very simple question. What do we do? Now, the voltage, the instantaneous voltage at time t is generally given as V naught sine omega t. This is the same thing as Vt is equals to V naught sine 2 pi ft. So we call this equation, let's call this equation number 1, equation number 2. So we solve this by comparing equation 1 with equation 2. So what do? You bring down this, so you have your V is equals to 311 sine 314.2t. You compare it with what? Let's put a t here to make it look the same. So you have also your Vt here is equals to V naught sine 2 pi ft. So these are the equations we have. Now, very simple. Your V naught, from here, your V naught is what? 311 volts. That's your V naught. And then your what? Your sine 3142t is the same thing as what? Sine 2 pi ft. So sine we cancel sine we cancel. Okay, sine we cancel sine, and then what are left with? You're left with 314.2t. 314.2t. Yeah. Point is here. A point is here, please. Do that quickly. 0.2t is equals to 2 pi ft. Okay, sorry, t, we also cancel t here. And then we don't have t on either side here. So, what are we left with? So you have 2f is equals to 314.2. Divide both sides by 2 pi. Divide both sides by 2 pi. This goes, this goes, this goes. Therefore, your f is equals to 314.2 divided by 2 pi. What do we have? You have 314.2 divided by 2 pi. So your frequency, therefore, your frequency F is 50 Hz. I guess that's what we have here as our option. The frequency is given. Yeah, I've got it right. The frequency is 50 Hz. So we are correct. So let's solve one last question before we call it a day. One last question before we call it a day. Let's clean this quickly. One last question. What is that question? The diagram below, this is the diagram. That is page 407, question 28. Exercise 5, calculations in physics. So the diagram, this is the diagram, this is question 28. This is the diagram. you have your inductor L connected in series with the capacitor, then with the resistor, then this is the ammeter, then your AC source. So in the diagram below, on the board, the resistor has a resistance. This is RCL. The resistor has a resistance 8 ohm, while the reactance of the inductor and the capacitor, reactance of the inductor is what? Is 10 ohm, and that of the capacitor is what? 16 ohm. 16 ohm. So respectively. So here is 130 volts, 50 hertz. 1 volts, 50 hertz. So calculate the current in the circuits. We are asked to calculate the current in the circuits. Okay? The current in the circuit is given from Ohm's law. V is equals to, that is the current in the circuit is not given. I, or flow through the circuit, is not given. So from Ohm's law, V is equals to IR. Our R here now is the impedance. So we write this is congruent to V is equals to I is equals to what? I Z. So V is already given. So V is already given as 130 volts. And so we have to look for impedance. We have to look for impedance before we find the current. So what is impedance? So impedance Z is equals to R, the root of R squared plus bracket XL minus X minus what? Minus XC or square. Mind you, this is our XL is equal to this, and then our XC is equal to what you see on the board. So if we substitute, we have the root of, we have 8 squared plus brackets 10 squared minus 16 squared. What do you have? You have 8 squared give us 64. 8 squared will give us 64. 64 plus 10 squared will give us 100. 100. 16 squared. 16 squared will give us 256 or square. So this is the same thing as, let's take this up quickly. So your Z is equals to the root of 64 into 64 plus into, you have 100 minus this, you have minus 156 squared. So if you do that, you have plus 24,336. So 64 plus the answer, plus that answer, will give you root 24,400. 24,400. So the square root of that. So Z is equal to 156.2 ohm. Let's check that again. Root 24,400 Yep, we are correct. So we have found the impedance in the circuit. So we can go ahead to calculate the current. So from V is equals to IZ, our I is equals to V all over Z. V all over Z. So if you substitute, this implies that our I is equals to 130 divided by 156.2. Do that, 130 divided by this, you have 0.832. Therefore, the current that will flow through the entire circuit is giving us 0.832 amp. So let's see if we are correct. I guess we are correct. Yes, we are correct. We are correct. So with this, we come to the end of today's class. It was nice engaging you in calculations in physics, in simple AC circuit. Stay blessed and stay safe. God bless you.